And I'm
You're muted.
muted. Thanks, Jesse. And we're live with the MongoDB podcast live. So glad to have you joining us. Hey, Jesse, how are you?
Good. How are you?
I'm doing great. A little bit of a rocky start this morning. What's going on? What are we talking about today, Jesse?
I think we're talking about MongoDB.
Ooh, my favorite subject. Apart from me, my favorite subject is MongoDB. So yes, if you're joining us, I see a lot of people coming into the stream on LinkedIn. It seems to be there's an intermittent problem with connecting to the stream. So I hope folks will bear with us. Hit that try again button, or you could jump over to the MongoDB YouTube channel and watch this thing on YouTube. We're going to be live on YouTube and LinkedIn. So so Jesse, how do you begin to think about using MongoDB if you're only used to SQL databases?
Yeah, that's the difficult part, because MongoDB is structured completely different. And so that's what we're going to talk about today is if you're coming from the SQL world, relational database, understanding really how to structure your data in a document database or non-relational. I kind of hate that terminology. We'll talk about different terminologies, but it's much different. And so we're going to talk about that today.
Yeah, awesome. Yeah, I'm excited. This is great because I think the audience that this is applicable to is really one that I love talking to. It's folks that are really curious and want to figure out how they can possibly leverage MongoDB. Adnan A is asking, will this be recorded? Yes, absolutely. It's being recorded and it will be available on YouTube after the fact and LinkedIn under the events page as well, I think. So great question. Thank you for asking that. So we are going to share some slides. And I know people like jump into a presentation. It's like, oh, slides. But we're only going to spend a little bit of time in slides just to set the stage. Let's talk to the audience first, though. Let's get folks, let's find out where folks are coming from. Folks are used to us asking that question. Oleg is already on the ball. He's letting us know he's from London.
It's
great to have you here. I'm in a little town called Newtown on the east coast of the United States. Where are you, Jesse?
I'm in Texas, East Texas, in the middle of the forest.
Nice. And what's it like there now?
Right now it's actually cold.
Is it?
For East Texas? What is the temperature right now? Let's see. It is 51.
Hey, look who's here. It's Michael Holler. Great to see you.
Germany.
Thanks for
Nice.
joining the stream. And Michael, please feel free to weigh in and ask questions and answer them as well. That's a key. We want folks to be interactive. Bring your questions. So we're going to start to go through the material very shortly. Would love to have your questions in the comments. Ask those questions in the comments. What do you say we jump into the
Yeah.
material?
Yeah. Yeah.
Sound
I
good?
see. I see another person that says no slides, please. But
No
again, it's
slides.
gonna be
We're gonna
it's gonna be
do we're gonna do
super brief.
slides minimum.
Yeah.
Minimum slides.
Yeah. The
Let me
point of
set
this
up.
is, um, like I said, is it's gonna be from a beginner standpoint of how do you get started with a different mindset in MongoDB.
Yeah, exactly. So let me share my screen. I should have this all set up. Like,
Yeah, it's
is
good.
is this guy a professional or not?
And just to acknowledge the other event going on right now, reInvent. I'm wearing my reInvent hoodie from
Oh,
last year.
sweet. Yeah, I
Yeah.
had my reInvent jacket on today.
Nice.
It's a little chilly this morning.
Yeah.
All right, so let me share that screen. And as we mentioned, this is an intro to MongoDB with a focus on data modeling. My name is Michael Lynn. I'm a developer advocate at MongoDB, and of course,
Yeah,
Jesse.
yeah, yeah. Jesse Hall, senior developer advocate, as well. You might also know me from my YouTube channel.
Awesome. Let's see. Let's move through really quickly. This is not intended to be this long 3-hour webinar droning on about stuff. It is recorded. You can come back and view it at any time. It is interactive. Please ask questions in the comments, open discussions. And if there's something that we can't answer, I'd love to have you jump into the MongoDB community forums. And those are at mongodb.com/community/forums. So it is interactive. There are no stupid questions. This doesn't mean don't ask stupid questions, because I don't think there are any stupid questions. But
Yeah, I always tell people if you're thinking it, there's probably someone else thinking it. So
I was
just say
thinking
it.
it.
It's
Yeah,
okay.
exactly. I think everybody in tech, to a degree, suffers from imposter syndrome. And if you're
Mhm,
sitting here watching this thinking, I'm not smart enough to ask this question, or I don't know all the context I need to ask this intelligently, just ask the question. Nobody's going
yeah,
to make fun of you or anything like that. So
yep.
there are many links, and they are down below in the description of the video. So would love to have you jump into those. That's all reference material for you, and we're going to be sharing some additional links for downloads that you can use in your journey to using MongoDB.
Mhm.
So Jesse, I'll ask you the question: why is data modeling so important?
Because you want your data access to be fast and efficient. And so understanding how to model your data properly is going to help assist with that.
Hmm,
I don't know. Is that a
absolutely.
good answer?
Well, yeah, I think so. And if anybody has another answer why they think data modeling is important, please feel free to put it in the comments. But this is kind of like the structured approach to data modeling. It is going to result in better performance. And by better performance, I don't mean just faster. I mean, it's going to be performance in line with the use case and the user, um, what's the word I'm looking for? The way that your application is
Mm,
used. That's what it's going to result in. It's going to be a simpler implementation that is scalable over time. It's going to ultimately lower your costs in a number of ways. We're going to touch on that. And ultimately, if you do it right, if you model your data correctly, it'll have better adaptability going forward. So MongoDB is often uh, thought of as a database where you don't have to model your data because, well, they say it's like NoSQL or it's schemaless.
mhm.
I prefer the term schema on read because the schema does exist. You do in your code create the model that is used, and you can even use tools to help you model like ODMs. Um, but people coming from an RDMS background or a tabular database background often get confused around what data modeling is for MongoDB, and we're going to touch on some
Mhm.
really key important topics, themes here to help you understand that.
Yeah, you can even
NoSQL,
you
yeah,
can even I'm sorry, you can even enforce a schema on the database side as well. So there definitely are
yeah,
schemas with MongoDB.
absolutely, yeah. That was my first thing, wrapping my head around a document database. I'm like, well, wait a minute, I can add a field at any time.
Mhm,
Well, that's got to be chaos, right?
mhm. Yeah,
No, it doesn't have to be. It can be very structured, and you can have validation using JSON schema as well. So the term NoSQL is confusing. Some people say non-relational, but I kind of like non-tabular. What do you use to refer to the type of database that MongoDB is?
Yeah, I think non-tabular, I guess, is the best. It's still not, I don't know, still not the best in my opinion, but
Yeah.
it is the best because NoSQL makes, I don't know, it just has a um, bad connotation, and non-relational makes people think that you can't store relationships in MongoDB, and so that's really the worst one in my opinion.
Yeah, yeah, non-relational. I mean, I think if anything else, it's more more relational.
Yes,
Um,
definitely store
but in
relationships in many different ways.
exactly. So in the non-tabular category of databases, there are many types, and they're all like the storage engine underneath supports these. So we're going to talk today about document databases. But there are also key value stores and wide column stores, graph databases, vector databases, which MongoDB is in that category as well. We're going
Mhm,
to focus today on document databases. And you might be asking, like, okay, so what is a document? I know like a Word document or a PDF document. Nope, it's not what we're talking about today. We're talking about a JSON document. And on the left, you've got an ERD representing a data model for, well, we've gone and done it, Jesse. We've
mhm,
used the relational term for a
yeah,
tabular
mhm,
data model on the left, and then
mhm,
we've got the same data represented in a document data
mhm,
data model. My
mhm.
my dog is joining in. I don't know if you can hear that, but
Yeah, I heard something.
she's barking.
Nice.
So anyway, what you see on the right is a document based perspective on this very same data model. It
Yeah.
begins with a curly brace, it ends in a curly brace, and you'll see that field, there are key value pairs in between. And some
Mhm,
of them are quite interesting because they're actually embedded documents and arrays of documents. You can get quite quite complex in the layout of your data.
mhm,
So just to give you a high level peek,
mhm,
data modeling is the process of figuring out how to represent and store data. That's all it is. That's all it is. It's a really key part of beginning to develop an application, though. In any with any database.
mhm.
Um,
Yeah.
so I forget what this is trying to show us.
Yeah. So the relationships here, we've got our tabular database, and
Mhm.
if you were to want to find books, let's see, select star from books, authors, reviews, where books author equals author. So you're trying to find all of the books with a certain author, and you would have to go to
Yeah,
all of these different tables in order to pull this information, to pull it back together. And
yeah,
that's just how a tabular database works. And also, when you think about data modeling in a tabular relational whatever database, generally you start with the data because there really is only there's one way to do it correctly.
yeah,
And you break everything up, you normalize everything, put it into tables. There's really no other way to do it. So you start with the data and you break it up and you do it that way. In a document database, or um, uh, well, I don't want to say non-relational. So in a document database,
right.
you you start completely opposite. You start at the application level. How are you going to access your data? And you generate your schema and your model that way, in the opposite way.
Yeah, awesome.
I think that's what we're going to see next. Kind of
Yep.
a different way
So
of storing it.
I kind of want to set the stage. We're going to focus on a specific application, right? So it always helps to like ground the theories that we're talking about around data model if we understand the application. And that's really the clue, a key to beginning to develop applications with MongoDB in mind. You start with the application, you start with the data, you break down the elements of data that you have. And today we're going to focus on uh, a library management system. So imagine that there are books in a library. Books have attributes associated with them. One of them is the title. It has a category, it's got a price, it's got an author. And then there can be this concept of a loan. You can have people borrowing books. So kind of keep
Mhm,
that use case or application in mind as we go forward. Um, in MongoDB, we refer to what you would call a table. We call that a collection, and it is a collection of documents. Where in the relational world, you would have a table with rows and columns in it. With MongoDB, you have a collection of documents, and the documents have key value pairs. So
mhm,
essentially, if you want to think about it this way, the keys, like title, would essentially be a column in a table in a relational uh, database.
mhm.
So I kind of think we kind of touched on this. I don't know how
Yeah.
much more we want to. Yeah,
Yeah.
you know what? Let's jump into let's jump into um,
And just to touch on that one
some
more
data.
time is starting with your application. Like instead of starting with the data, we're starting with the application and the use case of accessing our data.
Hmm.
And the thing that we always like to say, I don't know if there was a slide for this, but data that is accessed together should be stored together. And so that's what you
Love
have to
that.
think about when you're designing your application is at on the certain page of your application, what data do I need? And that
Yeah,
data should ideally be located together.
yeah. I love that. That's the mantra. We always talk about that. Like when you're thinking about data modeling in MongoDB, if there's one thing, right, it's data that will be accessed together should be stored together. And we're going to show you how to accomplish that. If you think about it, like in the tabular world, data that is accessed together is almost always separated.
Joined.
Joined. Yeah, you have to
Yeah.
join it. And
Mhm.
a join of two tables, how many reads on disk is that?
Mm.
At
Yeah,
least one,
depends
at
on
least two.
yeah,
Yeah.
at least 2, you could have many, many tables that you're trying to pull from.
Yeah. So it's about efficiency.
Yeah.
Okay. So let's dive into our use case, and I want to start by showing an entity relationship diagram. So I'm going to share my screen, and I'm going to show you. Don't get wrapped around the axle with the tool that I'm using. You can certainly use this tool, but I'm just using it for the ERD capabilities. This is going to be Hackalade. Can you see that? No.
No, I'm not seeing your screen. I think
Huh.
you'll have to
Refuses
share.
to share that.
Mm.
Let's try this again. Window. Accolade, share. There we the browser can't access your screen.
You might have to
Hmm.
share your whole
Well,
screen.
that could slow us down a little bit. Um, let me just try to share. Hmm. How about if I share the entire screen? Hmm.
Maybe. No?
Oh boy. Well, how about if I share? I'm going to go to a different tool. We
Okay.
can be very dynamic. Let's share.
Well, while you're doing that, so we talked about having the data together that is accessed together in the same document. That's the ideal situation. But you can also, if the data is not, if it's sparsely accessed from time to time, you can still do, it's not called a join, but it's basically a join in MongoDB as well, where you'll pull in some extra data from another collection here and there as needed. But we'll show you a few different ways of going about that and modeling your data. All right, you got it going.
Yeah. Okay. So this we're getting ahead a little bit. I
Mhm.
was going to show you this a little later, but what I'm going to dive into here is Relational Migrator. And don't worry too much about downloading it right away. We're going to give you a link shortly. But what one of the things that Relational Migrator can do is connect to your tabular database and give you an ERD, an entity relationship diagram, so you can see the table layout, and then it'll guide you through the process of creating a document based database. So let's dive in. I have a MySQL database running on my laptop here, and I'm going to create a new project. I'm going to start from scratch. Now we're in Relational Migrator. I'm going to connect to a live database. So I'll click that. And I'm going to connect to a MySQL database, and I'm going to type the JDBC connection string. This is really testing my abilities here. It's on my local host, 3306, I think. And the database name is LMS. And my password is going to be hidden, I hope.
It is.
Okay. All right.
No, it's
Okay,
localhost
let's
anyway, so it wouldn't go down.
yes, it did connect. Okay, so it connects to the database and it looks at all the databases. So fortunately, I just have one. You may have many, but I'm going to select the LMS database. I'm going to try to.
It looks like you're maybe frozen.
I am. Okay.
Oh, now it's no, wait. Hmm. Uh-oh.
Yeah, this happens from time to time with StreamYard. For some reason, it freezes up on me, so I'll be right back.
Okay.
Dance. I don't know. Ask questions.
Okay.
Hey, folks that are joining the stream, Jesse's going to explain what we're talking about. If you just joined us,
Yep.
we'd love to get your questions around data modeling and MongoDB. I'll be right back.
Yep. Sounds good. So yes, we're going to talk about how to model your data in MongoDB because it is very different from a SQL database. And there is a question here. Sean asked how you can avoid documents getting so big that they hit the document size limit. So we talked about how we want to store data that is accessed together should be stored together. So if you think about a page and how much data you want to access, you do want to break that up to a certain degree. So if you're like, we're talking about a books collection here, if you did a search that returned 10,000 books, you would want to paginate that somehow, right? But what if an author, for instance, could have many books? What if that author had 1,000,000 books? You wouldn't want to store all of that information in a single document. You'd want to then separate it. So we're going to talk about a few different ways that you can do that today in the stream. And there are different methods of structuring your data because you do want to be careful to not hit that limit in that document size. So we'll get to that in a bit. You're
Great.
not frozen. We have another question here about connecting to MongoDB with ODBC in environments that don't have native MongoDB driver. So there is the Atlas SQL. Was that? Let's see if was that shared. I think
Atlas
that was
SQL?
shared. Yeah, Atlas SQL. That might be an option. Or we also have HTTPS endpoints, which could be another option to access your data. So anywhere where the native driver is not supported, you could go into Atlas and set up an HTTPS endpoint. Pretty simple.
Data API.
Mm-hmm.
Great. Okay. So while I was gone, I'm launching my Atlas instance. So we're gonna dive into Atlas. You're gonna see how to use MongoDB Atlas, and you're gonna dive into relational migrator. So let's try and get back into that. I'm gonna share a tab, present, share screen, Chrome tab, relational migrator. Let's try this again. Okay, can we see that?
Yes.
Okay, awesome. So relational migrator is a tool that enables you to connect to a tabular database and envision what your world might look like with MongoDB and documents. So I'm going to create a new project, start from scratch, connect to database, and I'm going to connect to a MySQL database, and I'll type the JDBC string, MySQL, localhost. I'm on 3306, and the database name is LMS. My crafty username is root. Password is super tricky. And I'm going to connect to that. It's going to connect and query all of the databases. I'm going to select the LMS database. I'll click next. How's the visibility there? Is it okay?
Yeah, it's a little
Is
larger
it
than
skewed?
before, but yeah,
Yeah.
a little bit. But no,
Okay.
that's good. That's good. We can
Okay.
still see it.
Great. All right. So I'll call this webinar. This is my project. And here's some interesting options that you have. There's casing options in SQL that you can change. We're going to keep it to the original casing settings. And then mappings. This is where we talk about the mappings from the tabular database to the document database. And I'm going to start with the most basic way that you can convert tabular to documents. And that's by using MongoDB schema that matches your relational schema. This is probably not a good thing to do across the board, but I want to show you how it works. So let's keep it there and I'll say done. Now it's going to open this view and I'm going to have to make it a little smaller. You won't be able to read everything, but I hope that's viewable. So
Yeah.
on the top, I'm going to change the view. On the left, we have the MySQL tabular setup, right? Each of these is a table in our database. We have our books table. Books have authors. Books also can be loaned to borrowers, and borrowers only exist in the relationship of the book to a loan. So this is
Yeah.
a foreign key setup.
Any way to zoom in a bit because it's not readable at all.
Oh, it's not. Okay.
Yeah.
How's that?
Yeah, maybe
Kind of.
can you just
Can I make
yeah,
it bigger? Does that help?
or can you just maybe have one pane to
I
begin
can't.
with?
You can't
Oh,
close
okay,
one
yeah, okay,
side. Yeah.
okay. No, no,
Let's
that's
see.
good.
Okay. Yeah, I wish I could kind of change this, but oh wait, let's see. View. Relational. There. How's that?
Okay, yeah, better.
Is that a
And
little better?
then yeah, zoom in a bit.
Okay. So you're gonna lose. How about if we tuck these in so that they're a little closer?
Hmm. Yeah,
And there we go.
yeah,
Is that a little
that's
better?
much better, much better.
Okay, great. So you get the idea. Here we
Mhm,
have tables, and the columns in each of the tables is displayed. Most of you that are coming from a tabular application development background, you're going to recognize this. This is
mhm,
an entity relationship diagram. So what we want to do is we want to create a mapping between this world and the MongoDB world.
mhm,
So if I look at the MongoDB side, because I'll scroll in a little bit, because we said just convert it to the same structure that the relational database had, what it did was it created collections, 4 collections, to match the tabular structure from the relational side. So it looks exactly the same.
mhm,
Now, this is it's effective, and you can roll with this. You can write your application to leverage multiple collections, but you're not going to really see much efficiency, right? Because when you issue your find or your select statements, like in the relational world, when you issue your find commands, you're going to have to use the $lookup command in MongoDB to join data from multiple collections.
mhm.
That's probably not the best thing in the world. So, what I'd like to start to show you, are there any questions before we dive into actually creating the model?
There was a question about anti-patterns of data modeling. Are there
Hmm.
anti-patterns? And of
Here's
course, there
one.
definitely are. And this is, yeah.
Yeah, here's one. It's tables to collections. That's an anti pattern. And what you'll end up with is a very inefficient structure, because you're going to be always joining data from multiple collections. When remember the mantra, data that is accessed together should be stored together. Every time I access a book and an author, I don't want to have to be issuing 2 reads from disk when I'm always going to be accessing the author as a part of the book. So why not collapse those and store the data from authors inside the book's collection? And we can do that. So let's tear this down. I'm going to show this again. I'm going to click on each one of the collections that we have here. So I'll start with books, and I'm going to just tear these down. So I'm going to delete the model that we've created for authors, delete for borrowers. Oops. Come on, Mike, get with it. Cancel. Let's delete. And last but not least, our loans. Let's delete that. So now we essentially have no model created on the MongoDB side. So I want to create one. So let's go to authors. Let's start with books, and let's add a MongoDB mapping, which essentially creates our model. So for every table in the relational world, I want to create a collection. In this case, it's our primary collection. So I want to do this. I want to create a new collection called books, and I want all fields, right? MongoDB will give you out of the box an ID, but just for simplicity's sake, we're going to keep the original book ID, which is the primary key from the relational side. So I'm going to keep it super simple and just save this. Okay. So that creates a collection reference with a definition for all the fields in our MongoDB document model. And if we were to look at this now, you would just see books. You wouldn't see any loan data or author data.
Mhm,
So I want to begin to understand the relationships between my books and my authors next. So I'm going to click on the relational side, the authors table, and I'm going to create a mapping. And here's where it gets interesting. Now, I could select new documents and create a brand new collection called authors. I don't want to do that. I want to I want to embed authors in the book's collection, because every time I access a book, I'm always accessing the author information. So I'm
mhm,
going to create embedded documents, and the parent collection is going to be books. And I'm going to embed that under the root, under a field called author. And I think that should do it.
mhm. And select all the fields. Yep.
Yep. So I could I could leave author ID selected, but that would duplicate it because look, in
Mm.
books, we have the author ID already.
Uh,
So I'm going to make this simple, and I'm going to have a field in my MongoDB collection called books. The field will be called author, and I'm
mhm.
going to embed all of the data associated with the author for this specific book. Okay.
Okay.
So follow me on this. And that's what it looks like.
Mhm.
So we've created a new embedded field. Look at this. It's an object. It's a JSON document within a JSON document.
Yep.
So I'm going to buzz through these really quickly and do the same thing for borrowers.
Mhm.
Okay. So I'm going to add a model, and I'm going to create oops, I need books, authors, loans. Is
And we
that
have a
accurate?
question. Is this recorded? Yes. Yes. This will be
Yes.
recorded. You can access it on YouTube or LinkedIn immediately after.
Yep. Okay. So I already have book ID and loan ID. I don't have borrower ID, so I'm gonna create this embedded field in the books collection,
Mhm.
and I'm gonna save that. So here now we're building out our embedded model. I have loans, and because I have loans, I want borrowers to be indicated as well. I want this information.
Mhm.
Now you can debate this.
Mhm.
I want embedded documents, and I want the parent to be books. I could I could prefix this with loans and the field name being borrower. But then if I do that, I'm going to want to remove borrower ID because all I want is the additional name and email information in the loan.
Mhm.
So this is like true embedding. So let's take a look at what that looks like. So this is embedding in within an embedded. And all of this looks great. Like this is a document, but I think
Yeah.
it makes most sense when we can actually see the data associated with this and not just the model.
Can
So,
you just go to the Mongo? Can you just show the MongoDB side and zoom in a
yep.
bit
Yeah, sure.
just to kind of see that final
Hmm.
um, as much as you can? Yeah.
Yeah.
Okay.
How's
Cool.
that?
Yeah. No, that's much better.
Okay.
So you've taken all those tables and put them into a single collection and then embedded the different things. So each book is going to have a single author. So why not have that in there? And then a book can be loaned out to many people. So that would be an array, right? Yeah, I see. Yeah.
Hmm.
Uh,
Yep.
it's hard to differentiate between the squiggly brackets and the square brackets.
Oh, yeah. So
No,
let
no,
me
there
super
you go.
zoom.
Yeah, yeah. So the loans will be an array because there can be many different borrowers. And then so we'll have an array and we'll have the loan date, the return date, the borrower's information, and so on. Nice. Okay.
Hmm.
That makes sense.
Hmm. So
Any
this is a
questions so
true,
far?
yeah.
Anybody? No.
Yep.
I don't see any questions.
Okay. I'm wondering what happens when I drop over here. Oh, you can see it. Great. Okay. So what we've done is we've created a basic model. We've moved from a referencing model in the relational world to an embedded model in the MongoDB world.
Mhm.
Now, what the thing I really love about Relational Migrator is not just this ability to visually map out my model and go from relational to MongoDB, but I can also I'm going to skip code generation because that's going to be super compelling for some of you. And I'm going to go right to data migration.
Mhm.
Now, data migration allows you to create a sync job, which takes the data from your relational system and
Mhm.
migrates it to MongoDB. And you can have this executed on a regular basis if you want to, so that you can continually migrate data.
Nice.
So I'll click create sync job. The first half of this is what we've already done. We've connected to a MySQL database. We've provided the username, and it doesn't repopulate the password, but I'm going to retype that. And it connects. Now it's asking you for the other side of this, the MongoDB side.
Mhm.
And that is where Atlas comes in. So we need to spend a few moments understanding how to create our MongoDB database. So I'm in my database deployment. I've already created my Atlas account for
Oh,
free.
we're not seeing Atlas.
Oh, I need to share that
Yeah, we're just
specific
seeing
tab.
Relational
Yep.
Migrator.
Okay.
Mhm.
All right.
Um,
So
and then also just to add to that, this could be a local MongoDB database or Atlas. Um, and for this
absolutely,
instance, we'll be using Atlas.
we'll
Mhm.
be using Atlas. And by the way, you can deploy a local instance of MongoDB using the Atlas command line interface.
Mhm.
So the Atlas CLI can deploy instances of MongoDB locally on your laptop or desktop for development purposes. And it can also deploy vector and search databases. So
Mhm.
a topic for another day.
Yeah.
This is my uh, let's see. These are my existing databases.
If you could zoom
I
in
have
quite
another
a bit.
project. Sorry?
And if you could zoom in as well whenever you
Okay,
get a
I will.
chance.
Yeah.
Mhm.
Webinar. Created a new project for webinar.
You have too many projects.
I have so many. I'm in the, what did I call it?
Are you in the right
Yeah.
org?
Yeah. Let's see. Projects. Let's go to project settings and let's just create a new project. I don't think I'll have time to do that. I need to find the right webinar. Webinar November 11. Oh, yeah. What did I call it?
Data
Data
modeling?
model.
Relational migrator?
1129. Here we go.
Nice.
All right. We're doing it live. Okay, so I set this up ahead of time, but you'll need to get an Atlas account. It's for free. I've deployed a totally free Atlas cluster, an M0 instance. If you want to see what that looks like, we can jump to the database tab. And
Yeah, actually, so everyone who, if you just joined randomly, you wouldn't have received an email, but everyone that
right.
was sent an invite was actually also given an intro to MongoDB recording that would have helped you to set up this initial database.
But setting up a database is just dead simple. You click the create button. You can select shared, and the instance
Region.
size is M0 down here. So you can obviously, if you can deploy a larger size, but if you want to do this for free, M0 is free forever. You can select. I'm not going to go into all the details about the regions you can select and the cloud provider. MongoDB Atlas is an application that lives above the hyperscalers. So you can select to store your MongoDB data in AWS, Google Cloud, and Azure. Today I'm going to be using AWS, and I'm on the East Coast, so I'm going to use the North Virginia region, which is close to me. I'm going to select M0, and I'm going to leave everything else default, click Create Cluster, and we're going to end up with something that looks like this. I called mine library. You can call your cluster whatever you like, but if we browse collections, it's going to be very boring, Jesse. There's no data. We don't have any data. I can load some sample data, some really great examples in the sample data set, but for now, I'm going to leave that empty, and I'm going to go to overview, and I'm going to get the connection string because I want to connect my relational migrator instance to MongoDB.
If you could zoom in just a bit there.
Oh yeah,
pretty small. You've got a widescreen.
Oh, how's that?
Yeah, that's better.
Okay, so this is the key thing here. You want this connection string. No, I want the connection string for drivers, Node.js. Here's what it looks like. Okay.
Yep.
Okay, I'm going to copy that, and I'm going to stop sharing, and then reshare.
And after you get that going, we've got quite a few questions.
Oh, great. Good. Okay, so here I'm going to paste in the relational migrator the connection string, and I'm going to be sure to replace the hidden password with my real password. Everybody look away. Jesse, make sure everybody's looking away.
Okay.
All right.
No, that's an easy password.
I think that's it. Oh no, wait. I made it super complex. Connection string does not contain a database. Okay, so we do need to give it a database connection. So I want it to be called, and the great thing about MongoDB is like the database does not have to exist. You don't have to go into the schema and create all the structures and columns and all that stuff. You can just give it the name of the database that you want it to create. And whether it exists or not, it's going to continue. So we'll connect, and there's some options here. We're going to run this in one-time mode, and I can select to drop it. It doesn't exist yet. And if there are errors, stop after 100. And if you want to verify the data, I don't. I'm just going to start this. So this is going to kick off a job that's connecting to the SQL database, and it's reading all of the tables, all of the collections, and it's referencing the mapping that we created. and it's populating my MongoDB database. So it completed. Okay, so let's just take a quick look at the stop screen, and should we pause for questions before we go look at the data, or do you want to look at the data?
Let's look at the data real quick.
Because
that might answer a few questions.
Okay, good. All right, so let's do Chrome tab, and we want to go to library. Okay, so this is just another tab, and here I'm going to close this out. And before we had no collections, but now if I click on the collections tab, we should have one. We do. There's one collection, or one database, and one collection. And here's the data. So I think that's probably pretty small. I'll do my best to show that. Let's see.
There you go.
So this is the data down here. So each of these is a document that has authors embedded and loans. And the loan is an array of objects. This one has one borrower. Okay, so you get the idea. So it migrated the data from MySQL to MongoDB. And I really have to lift a finger to write any code.
Yeah.
So
and the nice thing about this is to pull this data requires one read instead of multiple having to join the data back together. But there are some caveats. And I think some of these questions we'll get into. Let's start with this one.
Yeah, there you go. Rosex was pointing out that nobody saw my password. Thank you.
Oh, yeah. Appreciate that.
All right. What about if you have, you want to read it? Go ahead.
Yeah. So if you have some names like strings, let's package names that can't keep them together in the main document because package name might change. I'm not sure I quite understand.
Yeah, maybe try and clarify that question, Mohammed.
Yeah, the key can't change, but the value could change. But yeah, maybe Mohammed, if you could clarify. Are you talking about the key or the value of the thing you're storing? So let's go to the next one. When author info is modified, we'll have to update the embedded document in all related books. Yes. So if the author changes his avatar picture, I don't know if there was an avatar picture in there, but yes, then you would have to go to all of that author's books and update that information there. So that is one caveat. One thing to keep in mind is when doing it this way, you do have possibly duplicated data, and that is a terrible thing in a relational tabular database world, but it's not a terrible thing in a non-tabular world. You want to expand upon that, Mike?
I'm not sure I understand. Embedded document in all related books. Oh yeah. So as the application developer, you are responsible for understanding the schema and maintaining it. So if you create a model that has embedded documents and you know that they exist in multiple places, first of all, I want to explain the concept of CODS rules for normalization. When you create a table design, a data model using a SQL-based, a tabular-based system, you are following rules. You are separating data. And the primary reason you do that is because back in the day, back in 1970, disk space was phenomenally expensive. So COD created this rule set which optimized for disk because disk was the most expensive thing. Today, flash forward 50 years, what's more expensive than disk? Your time. So you as the application developer need to be able to move quickly, design a schema that works, that's just easy and efficient. So we want to reduce the amount of time you have to spend working on separating your data so that you can have a flexible, fast, efficient system. And what that means is that you get to choose how your application manages the data. So if you create an embedded model versus a reference model, you don't have to separate the data, and you do need to write into your code the ability to update that data in multiple places if it exists, if you create that schema. And what the bet is that you're going to spend less time writing code to manipulate that than you would have in the case where your application is having to join every single read. Every single time you access books, you access authors, there's incremental time spent grabbing that additional data and complexity associated with not being able to scale out tables because they are distributed. It's so much easier to scale when all of your data is in one place. So I hope that answers your question.
Yeah, and to add on top of that, there could be a use case for even having an author collection.
Hmm.
Because you probably have the author probably has a profile, and
Hmm.
you want to go to that profile without having to read a billion books and finding that author's information from the embeddings in the book, right? You want an author
Yep.
table just for that. So again, you're starting with the application use case. This page in the application is the author's profile. And so that would pull only the information that it needs, which would come from an author collection. So you could have that author information all over the place, which sounds terrible. But but you could set it up in a way that when the author updates their profile, which updates the author collection, you can actually set up, I don't know if we're going to talk about this, but you could set up a trigger in Atlas, in MongoDB, that would say when this author collection updates, go update all the other places where it might be. Um, and so yes, it's okay to have duplicate data, but what we're focusing on here is really fast reads. This is
Yeah.
yeah. So
Yep.
all
Okay,
right.
so I've got a link up there. If you want to download Relational Migrator, it's free. You can download it from the link on the screen. It's mdb.link/DMW for data modeling webinar -RM for Relational Migrator. So DMW-RM. Check that out, and you can do just what we've done today. If you have a MySQL or a relational database that you want to, play around and create mappings, you can certainly check that out. I wonder if it would be helpful to look at this data in Compass. I don't know.
Maybe.
Are there any other questions?
Yeah, this is kind of related. In DBMS, you could argue that authors is the parent table of books, and in MongoDB is the other way around. Is that always the logic? And so I think we kind of clarified that as there really is no parent-child relationship in this instance. There's an embedding of author within the books, because every time you pull a book in, you're always going to want the author. So we don't
Mhm.
want to have to do that lookup. But there could also be an author collection that only pulls the author information when only that is needed, and we're not looking at books. Does that make sense? So yeah,
Yeah.
it's again, like, you could have multiple models going on at the same time, depending on how you're going to be accessing your data. Every page in your application is going to access data in a different way. And so you could have a different data model for each time you access your data.
Yeah. Um, Here's another one. Oh,
Yep, good.
coming from DynamoDB. Unfortunately, I don't have a whole lot of experience with DynamoDB. I understand it's a fairly simple implementation of a document database.
Mhm.
And I think there are a few more restrictions around the sizes of indexes and the size of the data store itself. But I think in the fact that it's a document database, it would the same rules would apply. I don't know
Yeah,
if
I
you know
would
anything more
assume the
about that.
same rules would apply.
Yeah.
Um, I think there was a question about AWS's implementation of MongoDB APIs as
Mhm.
well. And so same rules would apply there. Um, then I thought there was another question. Yeah, here's another question here.
Mhm.
Um,
Sub-collection concept in MongoDB like we have on Google Firestore. Sub-collection. So
mm,
we don't have a sub-collection. There's no relationship between collections. What we have and how we would represent that very same relationship between those elements that you've created a sub-collection for is we would embed those in a collection. So we would have a single data model with an embedded document, an embedded object inside a document to represent that relationship. So I think what you're trying to accomplish is efficiency on read for related items, expressing a
right.
relationship through embedding.
Mhm.
I hope that answers your question. You can feel free to comment if
Yeah.
not.
Yeah, and there's pros and cons both ways. What are you trying to be more efficient at? Do you have a page that is getting billions of views and you need to optimize for reads? Or do you have something that's updating constantly? You need to optimize for writes. So
Mhm.
when you're optimizing for writes, you don't want the duplication of data. But when you're optimizing for reads, the duplication of data is okay.
Yeah. Good point.
All right. Here's another one. We have two models, user and book. We give user reference in the book by ID. Now we have to search into the book model by user's name or any other field that exists in the user model, not by the book model. I guess if you're looking for a specific author, maybe.
Yeah. So MongoDB has an expressive query language, just like SQL. We call it MongoDB query language, and it enables you to be quite expressive in the way that you access the data. We use a different structure for our commands, but you'd use the find command, and you can leverage any field within a document to access data. So I can search and find. Would it be helpful if I show this? I can show MongoDB Compass, which is a really great tool. Share screen. Let's share a window. MongoDB Compass. You're going to have to let me know if that's visible.
Yeah, that's good.
Okay. All right. So I'm connected to my database that I just migrated. You can see my LMS database and the books collection. Here, I can begin to search by elements in the database. I can say, I'll quote this, author ID equal to 1. Okay. And then I hit the find button, and that shows me it's only one document with the author ID of 1. But I can also be quite flexible. I can say with genre equal to novel. Novel's a string, so I'm going to quote it. And there's only one there too. Probably this is a really simple database, but you get the idea. If there were multiple, it would appear here. So you can also use the aggregation framework. And what this shows you is that this is a visual way of viewing an aggregation. Aggregations have stages, and it's like a pipeline, where in SQL you get this run-on like join structure that can be like pages and pages of left outer join and filtering and grouping and summing. The MongoDB aggregation framework is quite nice in that it creates a very logical set of stages. And the first stage is typically a match. So I can create a stage, and I can use the match operator. This is $match. And I can say the same way I would do a find, I can say author ID 1, and it's going to show me the result set. I wish I had more data with this, because I could then add another stage where I could say, I don't know, group. I could group by and give the expression to group by and do a sum. So I only have one document with each attribute. So it's going to be difficult to demonstrate this, but imagine that you can get quite complex in building out these stages. And once you build the stage out, you can then, in Compass, you can save it. You can actually, this is the coolest thing. Have you tried this yet? Generate aggregation?
Oh, yeah.
I'm not prepped
I
to
didn't
show
try
this
it.
because I'll have to do all sorts of machinations to log in. But this is using AI. And what you can do with this is you can use natural language to build an aggregation. So I could tell it, give me all books with the author and give the name F. Scott Fitzgerald that were published before 1935. And it will generate the aggregation syntax for you. So really powerful. And I think I should probably show this. If folks want to see and play with Compass on your own, you can do that. You can download Compass at this link, mdb.link/dmw-compass.
Okay.
How about questions? We got any more?
Yeah, there's another question. So separating the books and authors data using the populate when querying for books have any performance. So that is the reason that we embedded the author in the books collection, because every time we access a book, we're always going to want that author, and we don't want to make that join. We don't want that second read. We want to get it all in one shot. And so that's the reason. So if you were to have them separated and basically do tables to collections equally from SQL to MongoDB, then you would have to do lookups, and you would have multiple reads going on, and that would have a degradation in performance. And so again, going back to not starting at the data level with your model, but starting at the application level. And again, each page in your application is going to access a certain subset of data. What is that? And model your data from front to back, not back to front. It's a completely different mindset.
Yeah, it really flips it on its end. This is a great comment, by the way.
Mm-hmm.
This is he's talking about. I'll read it. If you'll query for the whole model, you'll need to manipulate and parse the output fields you want, right? And he's saying you should use $project instead to limit the fields that you want to keep in your results. You want to avoid excessive amounts of fields in your model when you're querying. So that's when modeling comes in. Keep the fields in a model which are required in a particular page. That's brilliant statement because you're really looking at your model as the lens through which the user will see the data. So the data model should reflect how your application is presenting the data to the user. If every time I'm using this application, I'm only displaying the book and the date, and that's the first page in the application, I will want to most likely create a model that represents that and shows a collection that has books and the book title and the book date of publish. And then because your application is facilitating a second click to get to that second screen, in that implementation, I would probably create a separate collection. Data that is accessed together should be stored together. And conversely, data that is not accessed together should not be stored together. Great. I don't know who said that, who that LinkedIn user is, but
so we're not saying create a books. Don't create a books collection with every single piece of data point possible and just throw it all into that document and it's like a catch-all. We're not saying that. Whatever data that you need on that page should be in that collection. If there is data in that collection that is not being displayed, it shouldn't be stored there. It should be stored somewhere else. If it's being accessed later sporadically, it's okay to do a lookup. It's okay to do a join from time to time. But whatever that initial page load needs, that should all be all that's in that collection.
Yeah. And shout out to Mark Smith, who is moderating today. He's answering questions as MongoDB, and Luce Carter, who's also, thank you so much, Luce and Mark. Questions.
Yeah, and then there's another one here, trade-off between space for speed. And yes, we talked about space used to be super expensive and now it's super cheap. So space is no longer a factor. Speed is what we want. And then yes, data maintenance. You do have to think about that ahead of time. And there are ways of mitigating that with Atlas triggers to automate the updates of the duplicated data and other various ways. And so these are things that you need to think about.
Awesome. So here's the LinkedIn user. It's Viraj Thakar, mug leader from India. Thank you.
Nice.
Thank you for your work in the community. We love mug leaders. We just had a great podcast episode with a couple of the MongoDB community champions. It's a great program over there. If you're interested in leading a MongoDB user group, head on over to mongodb.com/community. There's a lot of details there about that program. So thank you, Viraj, for the great comment.
Great community.
Yeah.
I think we have time for just one last question. I think Mark already answered this from Ismail, and it's talking about migrations. And migrations is a thing in SQL databases, but migrations is not a thing for MongoDB. There are no migrations needed, but when you do make schema changes, this is not something that we talked about, but it's a good practice to use schema versions in your documents and tie that into your application as well. But that's kind of a whole nother subject. I don't know if we have time to get into.
All right, I want to take this last one before we end. How would a student class model look like in MongoDB versus RDBMS? The answer is it depends. It depends on what the application is going to do with the data. If, for example, you're always displaying on the front page student information only, and then on another page displaying class information only, and it's high traffic, there's a lot of students accessing it, I would want to think about the performance characteristics of the application to determine and inform the layout of the data in the data model. That may tell me that I need to create two collections, one with students and one with classes. And in the student model, then I might create an array of classes that the student subscribes to. That way I've got the embedded model for students and a referenced model for classes. It's one way to slice it. But if you're always displaying the two, it may make more sense for you to use an embedded model, just like we showed today.
Yeah.
So once again, I want to show these banners before. Go ahead.
While you're showing the banners, like we talked about, there in SQL, you have your data set, and there is really just one way of doing it. But in MongoDB, you have your data set, and even if we look at your data, we don't know how we would model it until we look at your application and how it's accessing the data. That's when we start modeling your data, is when we see how you're accessing it.
Yeah, great. And the last thing I want to say is download Relational Migrator. It's a great tool to let you even envision your tabular structures and see what they might look like in MongoDB. What I didn't touch on, which is so mind-blowingly powerful, is it will generate code for you. If you're leveraging a popular framework or language, there's a code generation tab built right into Relational Migrator that will give you the stubs, the boilerplate code that will enable you to connect to the database and reference and access the data and even update it. So awesome. I think that's about all the time we have.
I think so. I think that we're at time. So thank you all for joining, and we'll see you again very soon.
All right. Thanks, everybody.
Bye.